All right, so I'm going to show you in this video about why the traditional algorithm has a problem, which is this right here. One question related to a multiplication procedure that is typically taught and explaining the problem with this approach. So we're going to use 18 times 42 for this, and 42 times 18. We'll set it up like this. So here is what we would normally do, right? 8 times 2 is 16. This is already the problem here. When our students are quote-unquote carrying the 1, they are not recognizing that this 1 is a group of tens. And then when they say our next step would be to do 8 times 4, they're not recognizing that it's actually 8 times 40 happening. 8 times 40 plus 10 is what's happening. But 8 times 4 is 32, 33. This is what they would think, 33. But in essence, we're representing 8 times 40, which is 320, plus 10, which is 330. And then our representation from left over, the 6. Then we tell students that they are supposed to put a 0 right here, but they don't understand why. That 0 is there because of the same thing. We're not saying 1 times 2 in this next step. We're saying 10 times 2, which would be 20. And that's where this 0 comes from. And we're not saying 1 times 4 in this next step. We're saying 10 times 40, which is 400, which is what this 4 is representing, is 4 hundredths. And from here, we would have them add this up, which is the same answer we've been getting. But what I'm going to tell him the problem with this traditional algorithm is students are not understanding the concept of place value when they're using this. They're not understanding that this 0 is actually representing all this 10 times 2 and 10 times 40 that we're doing up here.